Yeah, the pile's definitely getting bigger. There's only a couple left. We've got the Fluke, the Klein tools, and the trusty Amprobe. Here's the box. I've added a whole nother capacitor bank into it. This will allow me to increase the voltage quite a bit. The box is basically run out of room. I have a bunch of Teflon shims inside of the box now to protect the new capacitor bank and isolate it from other high voltage areas. It seems to work fine. It's not breaking down at all. It should be okay to run these few tests. We're running high enough voltages now. I'm not really comfortable using these anymore. If they were to arc over, I'm a little concerned that I could damage the oscilloscope. So for now, I'm just going to set these aside, and I'm going to use my Tektronix probe. This is a P6113A. This is good for 12 kilovolts, which will be fine for the testing from here on forward. So looking at the LaCroix, you can see we're 5 microseconds per division, 2000 volts per division vertically, and basically 5 kilovolts. The last test was at 3.7 kilovolts, and we've jumped it all the way up to 5 kilovolts. I'm comfortable now that the meters that remain probably do pass their standard, so that pulse would be 6,000 volts. You can see here too, the decay is slightly shorter. Again, this is 5 microseconds per division. You're looking at about a 40 microsecond decay into an open right now, so it's a little shy of what the standard would be. Let's just see if the meters will handle this. Okay, the first up is going to be this UNI-T UT-90A. Again, this meter is damaged in the diode mode now. It no longer reads open circuit like it should. This is the only problem that I've got with the meter. The rest of it seems 100% functional. What I'd like to do here is just go ahead and finish it off. I assume it's not going to take a whole lot more to damage it. So again, you can see here I've got my Tektronix probe now attached to monitor the voltage. The homemade probes are just not going to be adequate for this, or they may be, but I don't trust them. So let's see how it holds up against the 5,000 volt hit here. This is about a 40 microsecond wide pulse. Okay, let's go ahead and hit it. Hey, it looks like we just fixed the meter. Huh. Now that's pretty interesting. I wonder if it works now. That's pretty funny. Oh, check that out. Ah, yep, zapping it seems to have actually, yeah, still got some leakage to her. Not good enough. Let's try her in the ohms. Yeah. Yep. I think we've just damaged it. We'll allow it to finish running here. Looks like it's still somewhat alive. No, we're missing it. I know. So this right now has a 50 volt signal applied to it. You can see it's reading 0 volts now. You get a little bit of a signal out in the millivolts range, but that's it. That's about 14 volts here. I'm assuming that the resistances don't work as well. Let's see here. So this is a 1 meg ohm. Yeah. So it's thinking it's 13 meg. This is a 100k ohm resistor. Let's put a 1k in there. Yep. Yeah, we've definitely damaged this. Yep. Input shorted. Just looking inside the UNI-T UT-90A. Again, I don't see any damage here. I suspect maybe between these two there's a PTC or something that cut loose. Yeah, I don't know. I think we'd have to pull the circuit board off. I'm just not that enthused to really have a look at it. All I know, it's failed. Here's the Amprobe AM510. Still functional for now. Let's see how it does at 5,000 volts. Holy crap. Okay, let's go ahead and test them out. And the UNI-T AM510 appears to be functional still. Makes it through a 5,000 volt test. Everything seems to work. That's a pretty impressive meter for 50 bucks. Next up is the Klein Tools MM500. .5,000 volt, 40 microsecond decay, 2 ohm source impedance. Ooh, we might have just damaged the Klein. Oh. Yep, we just lost the display. Well, there you have it. The Klein tool is down for the count. Oh, she comes back. Check that out. Let's hit her again here. Oh, down again. Huh. Maybe that should tell me something. Bunch of successive leaks. I haven't had the manual out yet for this thing. I don't see anything in our instruction sheet here that talks about what to do when it's beeping like this. try her in ohms. Oh, hard to tell if it's in ohms or not. Yeah, I'd like to know what's going on with this meter. You see the arc down here? Big flash. Wow. Let's try flipping the leads here. Yeah, we've shorted the input. Maybe it's going to play some musical chairs here. Still reading the right voltage, sorta. Down it goes. Alright, assuming here that it comes back. It's almost like the microprocessor or something's getting lost. It gets reset or something. I don't know. I don't know what's going on. So the AC voltage there appears to be correct. Let's try her in DC mode. Should be about 50 volts. Oh, there she goes. That's about right. It's about 10 volts. Looks good. Zero ohms. Yep. Yep. See here, nothing's even attached to it. Yeah, so something happened. We took out the front end for the ohms. Yeah. Well, Klein tools, the MM500. It was tougher than all these meters here. It is not tougher than the Amprobe AM510. It's down to 2. It's this and our Fluke. He's out. The last meter to take the stand, the Fluke 101. We may have a winner here tonight. Let's just have a look. Okay, the Fluke 101. 5,000 volts, 2 ohm source, 40 microsecond decay. Okay, that's it for the Fluke. Let's go ahead and check them out. And the Fluke survives. 2 meters left. The Fluke 101 and the Amprobe. These are both recommended by EV blog members. It's kind of funny, it comes down to these last two. So now I'm kind of curious on what it's going to take to blow them up. Well, we've lost a lot of meters during this testing. You can see our little homemade generator left a wake of damage in its path. We're down to 2 meters. We have the Fluke 101 and the Amprobe AM510. Who knows what it's going to take to blow these two up. Stay tuned while I try to figure that out.